Okay, we're going to look at a couple things in this first section. We're going to look at just the definition of a limit, and then also be able to find a limit from a graph. Now, just a preliminary definition of a limit, is in the formal definition, is if you have a function f that's defined for all values of x near a number, so we're going to be looking at a specific x value, x equal to a, so that a is our number that we're looking at. Now, let's say maybe the function doesn't actually have a value there, so there might be a hole in the graph somehow. So if f is arbitrarily close to some number L, now I'm talking about the y values. If the function's values are close to L for all the x's that are close to a, then we say that the limit of the function, so here's the function's values, is x approaching a, we're going to be close to the value L. That's the definition of a limit. So you're looking at what is the function's values approaching as the x is getting closer and closer to the a. So the main thing to keep in mind when you're looking at the limit here is you're talking about, this is y values. So that's going to be real important when we start looking at the graphs. We're going to want to look at what are the y values close to as the x's are close to some specific number. Okay, so now let's use this graph, and I want to identify some of the function values and limits. Okay, first thing I want to find is f of 1. You know this notation from algebra. That just means the y value associated with x equal to 1. So look at the graph where the x is equal to 1. What is the y value? Well, the y value at x equal 1 would be 2. This the y value of that point. If you go straight up and hit the curve, it's the y value of that point on the graph. So f of 1 would be equal to 2. Now I want the limit of the function as x approaches 1. What that means is I'm going to be looking at x values close to 1. Well, let me look at an x value close to 1 on the left side here. If I'm looking at all the x values here getting closer and closer to 1, what are their y values? Well, let's look at just individual points. At this point right here, here's the y value. It's, 1.8 approximately. Now get a point with an x closer to 1, so maybe 0.5. The y value there would be maybe 1.9. As I'm choosing y values or x values closer and closer here to 1, what are the y values doing? What are they getting closer and closer to? Well, this first one I was at about approximately 1.8. The second one I was approximately at 1.9. You can see that the y values, as the x's are closer and closer to 1, the y values are getting closer and closer to whatever the y value of that point is, which is 2. So we would say that the limit of f of x as x approaches 1 is also equal to 2. You're finding the y values. What are the y values getting close to as the x's are getting close to 1? Now, notice I was choosing x's that were smaller than 1. I could just as easily have chosen x's over here a little larger than 1. See, for this at 1.5 here, what's my y value? Well, it's whatever the y value would be for that point right here where the graph has an x value of 1.5. And that looks like maybe 2.3. Now choose my x value closer to 1. Now my y value would be here, whatever the y value is associated with that point, which would be, 2.1. As I'm getting closer and closer, as my x's are getting closer and closer to 1 on the right side with numbers bigger than 1, what are my y values approaching? Well, the y values are approaching whatever the y is at that one point, which again is going to be 2. So this here, the limit of f as x approaches 1, this means you're letting x approach 1 from either side of 1, either looking at values smaller than 1 or looking at values bigger than 1. But either way, you're looking for what is the y value that those x's are getting close to as you get closer to the x equal 1. Okay, the next one, f of 2. Now I want to look at where x is equal to 2. And now, what is f of 2? F of 2 is the y value when x is 2. Go up and find where's the point on the graph. The graph is the part in black. Where's the point when the x is 2? Well, it's not, there's a hole here in the middle of the graph. But if I keep going up, I see a point. That is the point on the graph. So that my y value when x is 2 is actually the 5. So I would have this point would be 2, 5. So now I want to look at limits. The limit exists even when there's not a y value at that point. So here we actually had a y value at 5. But now let's look at the difference between it and the limit. This means to look at x values getting closer to 2. So let me first start at 1.5. Well, where's the point when the x is 1.5? It's right here. Now look at 1 3/4. Where's the y value when x is 1 3/4? Well, it would be whatever the y value is at that point. And now let my x get closer to 2. As the x is getting closer to 2, the y's are getting closer to this point right here. There's not a point there. There's a hole there, but that tells me what the y value would be if there were a point there. Okay? I'm just looking at x's where the x is not 2, but numbers a little smaller than 2. So now the y value that those numbers are getting close to is 3. So I would say that the limit then of the function as the x is approaching 2 looks like 3. Now, all I looked at, though, were x's that were smaller than 2. What if I had x's bigger than 2? What if I started at 2.5? Where's the point? The point would be right here. Now pick one closer to the 2. I would be at a point right here. Even closer, I would be at a point here. As my x values are getting closer to 2, now I'm looking at numbers bigger than 2, what are my y values getting close to? Well, they're getting close to whatever the y value would be getting closer to as I get closer to 2, which would be, again, 3. So it doesn't matter here when I'm approaching 2. This means look at numbers smaller than 2 and look at numbers bigger than 2. And each time, let the x's get closer to 2 and what are the y values doing? So the limit as x approaches 2 is 3. And now let's look at f of 3. In the graph, f of 3 would be the y value associated with x equal 3. Well, x equal 3, I go up and there's a hole there. There's no y value. And nowhere up and down would I find a point that's solid. So there is no value f of 3. F of 3 does not exist. There's got to be a dot somewhere, or the line has to be filled in for there to be a value at x equal 3. So now let's see if there's a limit, though. So even when the function doesn't exist, the limit still might exist. So I want to find the limit as x approaches 3. So again, I'm going to look at numbers a little bit smaller than 3. And I want to find out what are the y values doing. So now I've got maybe 2.5. Well, at 2.5, the y value would be the y value of that point. So what, about 3.8? Now I get an x a little closer to 3. So now I'm at maybe 2 3/4. So now my point would be right here, and the y value is a little bit under 4. Notice as x gets closer and closer to 3, the y values are getting closer and closer to whatever the y value would be at that point where there's the hole, which would be 4. Okay, so that's at least looking at numbers smaller than 3. Now let's look at numbers a little bigger than 3. So maybe 3.5. Where's the point that would be associated with x equal 3.5? Would be right here. 3 1/4 would be right here. Let the x get closer and closer to 3, and each time you're getting a point whose y value is getting closer and closer to 4 again. So either side, whether we're looking at x is smaller than 3 or larger than 3, the y value either side is getting closer and closer to 4. So that's what the limit of f of x is as x approaches 3. Okay? Notice that the value of the limit did not depend on the function's value. You know, the first example, f of 1 was 2, and that was the limit. The second one, the limit was 3, but f of 2 was actually 5. In the third one, we didn't even have a function value, but we had a limit. Okay, so now I want to look at a table of values. The graph you can only tell so much from. Sometimes you need to look at what the values themselves are. So what I'm going to do is I'm trying to find the limit as x approaches 1. I need to look at x values smaller than 1, getting closer to 1, and also x values that are a little bit bigger than 1. Okay? So I'm going to look at it this way. I'm going to have my x values, and I'm going to use 0.9. Then we'll get closer to 1. So let's say 0.99, 0.999. Okay, so these values are getting closer to 1. And I want to find out what are the function's values. Okay, so f of x now. Now if I plug in 0.9 into this function, I want f of 0.9, that comes out to be 0.5131670. Now I'm going to plug in 0.99 into this function again, and I'm going to come up with 0.5012563. And now I'm going to plug in 0.999 into the function f. And when you do, you end up with 0.5001251. Okay, now I'm going to choose numbers a little bigger than 1. So let me start down here at the bottom and say 1.1. And then I want to get closer, so I'm going to say 1.01. And then let's say 1.001. So I'm having the values get closer to 1. Okay, when I plug in 1.1, I end up with 0.4880885. Plug in 1.01, I get 0.4987562. 1.001, I would get 0.4998750. Now I'm trying to find this value. Now notice if I put in x equal to 1 into that equation, I get 0 over 0, which is undefined. So f of 1 does not exist. But I do want to find out what the limit is, if it exists. So what I'm going to do is I'm going to look at the values in my table. As the x is getting closer to 1, what are the y values getting close to? Well, just looking at these three values, it looks like they're getting closer and closer to 1/2. Coming the other direction, 1.1, 1.01, I'm getting closer and closer to 1. What do you see about the y values? They're getting closer and closer to 0.5 also. So this would be the limit of that function as x approaches 1. Now you'll see it written this way where they'll just use f of x. They may also write it as the limit of the square root of x minus 1 over x minus 1 as x approaches 1. And you could say 0.5. So they could put the actual definition of the function in there behind the limit.